Hey y'all, in this problem we are going to go over an elevator problem. We have Bob, who's 90 kilograms. He's getting on an elevator and standing on a scale, and he's going to start on the ground floor, and each floor is 4 meters tall. We're going to go through how to do the free body diagrams and what the scale reads. We're going to go through some motion graphs as well as determine how many floors he's going up. So let's start off with these motion graphs. So first off, we have Bob on his elevator, and he is standing on a scale on it, and that elevator is going up. So we want to determine what forces are acting on Bob as he travels in this elevator. So every time you have an object, you're going to have force of gravity acting on the object every time. So before we even look at scenarios, we know all of these free body diagrams are going to have force of gravity. Force of gravity, to find it, is going to be your mass times the acceleration due to gravity on that planet. In this case, it doesn't tell us we're not on Earth, so we're going to assume we're on Earth. So our mass of Bob is 90 kilograms, and then the acceleration due to gravity on Earth is 9.8 meters per second squared. We're going to multiply that, and we get a force of gravity of 784 newtons. So for all of these, it's going to be 784 newtons. And you don't even need to look at the situations at this point. I mean, you can, but you don't have to yet. All right, so that's easy enough to start. Now we want to look at what the elevator is doing, because if it's accelerating, our net force will not be zero. If it's constant or at rest, our acceleration or our net force will be zero. So for this first one here, we have an elevator speeding up at 2 meters per second squared for 4 seconds. We need to find our net force here. So to do that, it's just F equals ma. So our net force is going to equal to Bob's mass of 90 kilograms times our acceleration on the elevator, which was 2 meters per second squared. We're going to multiply that, and we get a net force of 180 newtons, and it's in the positive direction. So that means it's going to be 180 newtons up for our net force. So we want to find this normal force here that the elevator and the scale is pushing up on Bob. We're going to add 180 newtons of our net force and add our force of gravity together to get that. And that is going to equal 944 newtons when we do that. So our scale is going to read not the force of gravity, but it's going to read this normal force. So our scale here is going to read 944 newtons right there. Okay. Now moving to the next one, we're going to do, it's the same idea but this time our elevator is moving constant. Let me switch back to a pen. It's moving constant velocity. So when we see constant velocity means our net force is 0 newtons there. So that means our normal force needs to be the same as our force of gravity. So this is going to be 784 newtons. Then our scale, it reads the normal force. That's going to be 784 newtons. Now for the last one, we're slowing down. We have a negative acceleration of -2. So it's the same deal as the first part. We're going to find our net force of our mass times our acceleration. Our mass of Bob was 90 kilograms. This time our acceleration is -2 meters per second squared, and we're going to multiply that and get negative 180 newtons for our net force. Now the same idea applies to find our normal force. It's going to be our net force plus our force of gravity. So we're going to have negative 180 newtons plus 784 newtons, and that's going to equal our normal force. And in that case, we're going to get 624 newtons. And that's what the scale is going to read, because our scale is going to read our normal force. So to recap, find your force of gravity by multiplying 90 kilograms of his mass times the acceleration due to gravity on Earth, which is 9.8, we get 784. And that's true for all of these scenarios. Then we're going to find our normal force. If it's constant velocity or at rest, like this middle one is, they'll be the same. And then if it's accelerating, either in the speeding up or slowing down, we're going to multiply our mass times our acceleration, and that's going to find our net force. And then we'll add our net force and our force of gravity together, and that gets us our normal force. So in which case, speeding up ends up being higher, and slowing down ends up being lower. Then we'll determine what the scale reads. It's going to be what your normal force is, because that's what the scale's pushing up on the person. So it'd be 944, 784, and 624. So that's all for part A. Now let's move on to part B. So for part B, we are drawing some graphs. Now I'm going to let you know in a little secret that your test isn't going to have you draw graphs, but you're still going to want to know what you're doing with these graphs. So this to me is a little bit harder than what I'm going to give you on the test. So for the graphs, this is going all the way back to the beginning of the year. We have position graph, velocity graph, acceleration time graph. So think about first just what the shapes and what direction your line should be going. So this elevator is going up. So on our position graph, our line's always going to be going up. So for those first 4 seconds, you were speeding up. So you want your curve to show speeding up, just like we did back then. Then we're going constant the next 8. So we're going to add on 8 seconds plus 4 would take us all the way to 12 seconds. We're going to go constant velocity there, and we have a diagonal line represents that. Then the last 4 seconds, that'll take us to 16 seconds total, and we're slowing down, so we want a curve that shows we're slowing down. And we'll come back to these y-axis numbers in a moment. Really, I want you to focus on this velocity graph. Your time interval will be the same, so 4, 12, and 16, and it'll be the same here eventually for your acceleration graph. And we want to go here for velocity. You're speeding up in the positive direction, so you're going to go up like that. Then we're going to be constant velocity for that middle, so that means a horizontal line. And it also tells us our velocity here is 8, so we can go ahead and mark that on the y-axis. And then the last 4, we're slowing down, and so we're going to end up back at 0. And we can make sure we end up back at 0 by looking at this -2, that for every second, we're going to drop -2. So we're going for 4 seconds, so we're going to drop a total of -8, which takes us back to 0. For the acceleration, this one's easy. You're just marking it at. So the first one, we're at an acceleration of 2. So it's going to be at +2. Then we're constant, so we're at 0. And then we're going to be at -2 down here. All right. So those are our graphs. To come back here, to fill in this y-axis here, we can get these numbers by doing the area on our velocity graph. So we're going to take this velocity graph here and find the area for each section. So for the first 4 seconds here, we get this triangle. We're going to do 1/2 times 4 times 8, and we're going to get an area of 16 meters. Then the second section is this nice rectangle. From 4 to 12 is 8 seconds total, times a height of 8, and that'd be 64 total. And then the last triangle would be 1/2 times 4 seconds times a height of 8 as well, so that's another 16 meters. So then we can come over here on this graph and go, first section goes 16, then we add on 64, which would be 80 total, and then I'm running out of room here, I didn't draw this well, but add on another 16 to that would be 96 meters total. So those are all in meters, and that's how that would be. But now this takes us into our last question of how many floors he goes up. So to find the total distance he travels, we're going to add all these up. So 16 plus 64 plus 16 is going to be a total distance of 96 meters that the elevator travels and Bob travels. To find out how many floors he's going up, we're going to divide that by the height of each floor. So 96 meters divided by the height of each floor, which we were given way back in the beginning of 4 meters, is going to equal a total of 24 floors. And that is our answer for C. And we are done.